All right, guys, welcome back to Algebra 2. So what we're going to talk about today is on the next page of your packet labeled compound events. Compound events are considered one of two things: independent or dependent. So before we get into what the difference between independent and dependent means for a compound event, we need to talk about what a compound event is. A compound event is a situation where multiple things need to occur, or we want to occur, right? We want to roll a dice and get a 5, and draw a card out of a deck and get an ace. We want both of those things to happen, right? And for us to find the probability of a compound event, we need to consider or find the probability of each individual event happening. What we talked about yesterday were simple events, one event, right? One thing needed to happen, and one thing only. But today, it's a little different. So when we talk about independent versus dependent, it really hinges upon the situation we're in. Does the situation of multiple different things happening, do they have any impact on each other? For example, in the dice and card scenario, if I want to roll a 5 and then draw an ace, does it have any direct impact on the card draw, whether or not I roll the 5 or not? You know, it doesn't, right? I'm rolling a dice over here, I'm drawing a card over there. They're two separate or independent events, meaning they do not have any impact on each other at all. They are entirely separate. But what about the scenario of saying, I want to draw an ace from a deck of cards. I'm going to put that card over there. And then I'm going to draw another ace. Well, think about it. Do those two have anything to do with each other? Absolutely. Because by drawing that first ace out and putting it off to the side, you're now changing the probability of drawing another ace from the deck, right? Because it went from 4 aces out of 52 cards. After you draw that first one, now there's only 3 left out of 51. So those are dependent. It's very important to recognize that our probability of the second event changed based on the first one happening. Now today we're only going to talk about independent events, but dependent events are going to come tomorrow. So let's take a look at the independent section of the paper. So it says a die is rolled 3 times. What is the probability of getting a 1 on each roll? So now I know this is on the independent section of the paper, but let's think about why it's independent. If you're rolling a dice 3 times, does each dice roll have any impact on the next one? No. It's not like you roll a dice and then magically that side of the dice just goes away, right? No, it stays the same. You have the same odds every time. So let's think about this. Like we said yesterday, to find the probability of an event, we want the number of successful outcomes over the total number of outcomes. So for the dice, we said we want to roll a 1, right? So we only have 1 successful outcome. Just a single 1. Out of the total number of outcomes, well, it's probably a 6-sided die, so there's 6 possible ways that this could go. Now, we want to find the probability of each event happening. We're rolling this dice 3 times, and the same stipulation on each one. A 1, a 1, and then a 1 again. So the odds of each of these events, the probability of each of these events, is the same. I'm going to label it. I'm going to say event 1, event 2, and event 3. My odds for event 1 was 1 out of 6. My probability for event 2 is 1 out of 6. My probability of event 3 is also 1 out of 6. to determine the overall probability of a compound event, or the probability of multiple things happening, what we do is we multiply these probabilities together. And you could do this in a calculator and get a decimal, but I much prefer you do this as a fraction. 1 out of 6 times 1 out of 6 times 1 out of 6. You guys know how to multiply fractions. All you do is you multiply straight across on top, straight across on bottom, right? So 1 times 1 times 1. Well, that's still 1. But in the denominator, we have 6 times 6 times 6. That's 216. So the odds of you rolling a 1 3 rolls in a row is 1 in 216. Pretty low odds, right? But that's how this works. Let's do one more example. A coin is tossed, then a day of the week is selected. What is the probability of getting a tails, then a day, starting with the letter T? Okay, well, let's think about this. So we have 2 events. The first event is flipping a coin, heads or tails. We want tails, so that's 1 successful outcome out of how many ways can a coin land? 2. We then want to choose a day of the week that starts with T. Well, let's think about this. How many total days of the week are there? 7. How many start with the letter T? Tuesday, Thursday. So there's 2 successful outcomes. So for us to find the probability of this compound event, we multiply the probability of event 1 by the probability of event 2. 1/2 times 2 over 7. 1 times 2 is 2. 2 times 7 is 14. That number can simplify. That can simplify as a fraction into 1 over 7. We have a 1 in 7 chance of both of those events happening. All right. So what I want you guys to try out is we have on independent events this little scenario. Right below the 2 we just tried out, it says a bag has a bunch of crayons, and you're going to use that for each of the examples. Now you'll see on 13 through 16, it does something like this. It says P and then like purple, then yellow. Something like that, right? This is just a mathematical way of saying the probability of this happening, then this happening. The probability of drawing a purple crayon, then a yellow crayon. So you'll notice that even though this sounds like it might be dependent, it actually is independent. The reason for that is because it says a bag contains all these crayons. A crayon is selected, then replaced, meaning it's put back in the bag, right? So does it impact the odds of you drawing a crayon the second time if you put the first one back? No, because the bag is holding the same number of crayons in the same distribution of colors on every single draw. It would be dependent, or it would start to change if we didn't put that crayon back in the bag. Let me know if you have any questions on 13 through 16. That's what I want you to try out if I didn't already say that. Let me know if you have any questions on those. Email me if you do. Otherwise, see you guys tomorrow.